In December 1978, a 260-meter supercarrier named the MS München was crossing the North Atlantic. It was one of the most sophisticated vessels ever built, designed to be virtually unsinkable. Yet, in the middle of a storm, it simply vanished. For a week, 100 ships and 13 aircraft scanned an area the size of Mexico, finding nothing but a single lifeboat. When investigators finally recovered that boat, they found something impossible. The heavy steel pins, located 20 meters above the waterline, hadn't just snapped, they were bent backward as if a massive, focused force had punched through them like a finger through a potato chip.
For centuries, scientists dismissed stories of such forces as sailors' yarns, no more real than mermaids or sea monsters. They believed, based on every linear mathematical model we had, that a wave of that magnitude could only occur once every 10,000 years. But on New Year's Day, 1995, a laser sensor on the Draupner oil rig in the North Sea recorded a single vertical wall of water 85 feet high. It was the first time science had to admit that the legends were true. Rogue waves weren't just possible, they were everywhere.
To understand why these are the ultimate drowning machines, we have to look at the math of modern shipbuilding. Most cargo ships today are built to withstand 15 tons of pressure per square meter. That is usually more than enough to handle a standard storm. But a rogue wave doesn't behave like a standard storm. It hits with a crushing force of 100 tons per square meter. It doesn't just toss a ship, it shatters the hull.
This happens through a process called constructive interference. Imagine waves from different weather systems, traveling at different speeds, suddenly piling up at a single point. It is like a magnifying glass focusing light into a deadly beam. The most terrifying version of this is known as the Three Sisters. These are three massive waves that hit in such rapid succession that a ship cannot recover its buoyancy after the first strike. By the time the third wave hits, the vessel is already buried under thousands of tons of water. Its electronics short-circuited and its engines dead.
But the danger isn't always a vertical wall of water. Sometimes it's a terrifyingly perfect geometry. If you ever look out at the ocean and see a grid of perfect squares looking like a giant chessboard made of moving water, you are seeing a cross sea. It looks enchanting, almost like a glitch in the Matrix, but it is a survival directive to get out of the water immediately. These squares are formed when two opposing swells intersect at 90-degree angles. Underneath that beautiful pattern are multi-directional riptides so powerful they can capsize a ship or drag even an Olympic-level swimmer miles into the deep before they realize they've left the shore.
What is truly haunting is where these waves get their power. Recent research suggests we have to look beyond traditional oceanography and into the strange world of quantum physics. Scientists have found that rogue waves follow the non-linear Schrödinger equation. This means that on a macro scale, the ocean is literally behaving like subatomic particles. A single wave can act as a predator, mathematically sucking the energy out of the smaller waves surrounding it, growing larger and steeper, while everything else around it becomes a shallow trough.
This brings us to a sobering realization. We are currently living in the myth of the unsinkable century. We have better GPS, better steel, and better weather tracking than any generation in history. Yet we are finding that our modern, rigid ships are actually more vulnerable to these events than the flexible wooden hulls of the past. As our oceans warm and storm systems become more erratic, these quantum anomalies are moving from the realm of legend into our daily reality.
We used to think you'd have to wait 100 lifetimes to see a 90-foot wave. Now, satellite data shows us that at least 10 of these monsters form somewhere in our oceans every 3 weeks. The ocean isn't just a body of water. It's a complex, unpredictable engine that doesn't care about our engineering limits. The next time you see the water turn into a perfect grid or a storm begins to rumble with an unusual frequency, remember, nature almost never uses straight lines. When it does, it's not a miracle, it's a warning.